Okay, so continuing on with calculus, we have a very tricky AS level maths question here, which asks about which tells us that we have a stationary point P, which is 3 and 5, coordinates 3 and 5, which lies on the curve y equals 1 over x minus 1 minus 9 over x minus 5. Okay, so this function here, the y equals 1 over x minus 1 minus 9 over x minus 5. I've just drawn this function for explanation, but you will not have to draw this function. It's a tricky function to know, and you don't actually need to know what this function looks like. However, just in explaining this answer, I've drawn the function just so that we can see how it works. So the first bit of the question, they're telling us that we have a function, a point P that lies on the function. So that's the 3 and 5. So let's say that that's around there. Okay, let me do it in a different color so it's more clear. So we'll do that in yellow. So what they're telling us is we have a point on a function that's 3 and 5. Okay, so we don't necessarily need to draw the point. I've simply just done it for explanation. But that's all they're really saying. We have a point that's on a function. Now, this question that's quite tricky, they've asked about the stationary points in P, which if I was designing the question would have been what I would have asked first, because I think it's actually much more complicated to answer A. So what I'm going to do, because this is for you to learn, is I'm actually going to do part B, which is something that is easier for us to do, because we know that when we find the stationary points, we are essentially finding the turning points, and that is where your derivative is 0. So as soon as you get asked for stationary points, this is where where the y dash is equal to 0. So that should be clear now. When you find the stationary points, the y dash, the derivative of your graph, is equal to 0. Now, A asks about the coordinates of the normal to the curve, which we'll go into next. So the normal to the curve just throws us a little bit of a curveball there, because we are asked about the normal to the curve rather than the tangent to the curve, which is a bit more what we get asked, which is then the tangent. We know the equation of the tangent to the graph. We know that the gradient of that tangent will be the derivative, because remember, when we differentiate, when we find the derivative, that is finding the slope of the graph. And we know that the slope of the graph would be at that point would then be the slope of the tangent. For example, if I was to do, I'm going to do this in pink now so that you can see the tangent to the graph, yeah, is going to look like that, right? Okay, so it's pink, and the tangent to the point would be in pink. And then we know the gradient of this line in pink would be the derivative when we differentiate the graph, and we would sub in our x value, which is 3. Okay. All right, so let's just look at question B now. So they say find the coordinates of the stationary points and determine the graph. So our stationary points are where there are the turning points, which is essentially, I'm going to do this in pink again. The stationary points will be where the tangent has no slope, right? It just goes parallel to the ground like that. So there are 2 tangents. Okay. I haven't drawn this graph exactly, so our answers may be slightly off, but the maths will tell us. But we know that it looks like there's going to be 2 turning points at that graph, so we're going to get 2 stationary points. All right, so finding the stationary points now, we find the derivative of this function, and we make that equal to 0 next. So let's first just find the derivative. So we have y equals that 1. Now, I want to use the chain rule here. And the chain rule, we need something in the brackets to the power of something. So in this case, so that x to the minus 1 that's at the bottom, I can take to the top and make it x minus 1 to the minus 1. So in other words, I am taking this x to the minus 1 and I'm taking it to the top, and then I can just put it to the power of minus 1, because now it's lining me up to do the chain rule. And then the same with the other function. I take the x minus 5 to the top, and that becomes x minus 1. Okay, so if you remember from GCSEs, that is the exponent rule that we're using, which let's remind ourselves, 1 over x is equal to x minus 1. So I can take, even if I had x squared, 1 over x squared, sorry, I could make that x to the minus 2. Okay, so you can move things around. If I had x minus 1 over y minus 1, I can just flip those. The y goes to the top and becomes positive 1, and the x goes to the bottom and becomes positive 1. So remember, exponents, you can do that, and you can switch between depending on what you need, how you need the function to look. So now we're going to do y dash, and we're going to do the inside-outside rule. So let's remind ourselves, I like to do the outside-inside rule. In other words, I like to do the outside first and then the inside. If you learn that you want to do the inside first and then the outside, that's fine. But I like to do the outside first because I like to just tag the inside along at the end. So we'll see how that works. If you haven't seen another video, you'll learn that now. So we have minus 1 times 1 is minus 1. So we're doing the outside first using the power rule. And then we take 1 off the 2, so it becomes minus 2. The inside stays the same. And now the final part of the chain rule is then to differentiate the inside. Derivative of x minus 1, well, the derivative of x is just 1. And minus 1, the derivative is 0, so I don't have to write that. Okay, now I'm going to do the outside of the next one. Minus 9 times minus 1 is plus 9. Leave the inside alone. Still got to do the rest of this outside, which is take 1 off the 1, minus 1, so that becomes minus 2 again. Now I find the derivative of the inside, which just so happens to also be 1. Okay, often the inside is a bit more complicated than that, but this time we've got it nice and easy. And so we have the function y dash, y dash equals negative x to the minus 1 to the minus 2 plus, because 9 times 1 is just 9, 9x to the minus 5 to the minus 2. Okay, so first part of the function is done. We found the derivative. The next step of finding my stationary points is to make that equal to 0. So 0 equals negative x minus 1 to the minus 2 plus 9x minus 5 to the minus 2. Now, I want to solve this. The easiest thing for me to do is just to take this negative x minus 1 to the minus 2 to the other side. And it becomes plus x minus 1 to the minus 2 equals 9x minus 5 to the minus 2. Okay, so you kind of got to know that you need to do that when you want to solve these, because then you can manipulate this by now writing it. So now with our exponent law, where we take things to the bottom and we change the sign, now we're actually going to end up going all the way back and actually taking the x minus 1 to the bottom and making it positive squared. And we're going to take the x minus 5 to, and we're going to take that to the bottom and make that positive 2. So you see how I'm manipulating my function using the exponent laws. So those are very important now that we learned in GCSEs. Now what I can do is essentially times both sides by x minus 1 squared. In other words, if I times this side by x minus 1 squared over 1, do you see that the x minus 1 squareds would cancel? And I could then put an x, when I times this side by x minus 1 squared, I would have 9x minus 1 squared. And so this would just be 1 equals. And then if I wanted to get rid of the x minus 5 squared at the bottom, I would then times both sides by x minus 5 squared. And of course, then they would cancel on this side, and we would have 1 times x minus 5 squared on both sides. And so I'd have the denominator on both sides removed. Okay, but I'm going to do a quick way. I'm going to show you a quick way that I like to do. And I'm just going to use arrows to show you what I'm going to do. Because there is no like plus 1 here. In other words, because I have two fractions, like say x minus y equals, let's say z over b. Because there is essentially no plus 1 here, I can actually just take my b to one side and my y to the other. So when it goes to the other side, it just goes to the top. When the b goes to the other side, it goes to the top. And I would end up with just bx equals zy. So I'm going to do that here. Okay, so I'm going to show you what I'm doing in, let's use a color. Purple, the color purple. So what I'm going to do is the x minus 5 is going to go to that side and go to the top. And the x minus 1 squared is going to go to that side and go to the top. Okay, this plus 1 wasn't here. And so that is going to equal. So when the x minus 5 squared goes to the top, it goes to the top of the left-hand side. So I'll have x minus 5 squared equals 9. And that x minus 1 squared has now gone to the top. So that joins the 9. And so I've simply got no denominator left. So that allows us then to square root both sides. Okay, so I can square root both sides, which means get rid of the squared. So that becomes x minus 5. So in other words, if let's do this in this light green again. So if I square root that and I square root that, the squares go away. And I'll have equals. Now the 9, the square root of 9 can either be plus or minus 3, right? Because minus 3 times minus 3 is equal to 9, but also 3 times 3 is equal to 9. So that it could have been minus 3 to get to 9. So that's why it's plus or minus. Okay, and this is now going to give us the two x values of our turning points. So we can do them each individually. X minus 5 equals, let's do the plus first. So that'll be 3x plus, minus 3. Let's do the negative next. So it'll be x minus 5 equals minus 3x plus 3. So then let's take this x to that side. So we get 3x minus x is 2x, minus 5 plus 3 is minus 2. And I get x equals minus 1. In this one, I get, take this, so I get 4x equals, this goes to that side and becomes 2. And I get x equals a half. Okay, so that probably would have been that point, and that would have been, I should have really moved this one. This one should be kind of a little bit to that like that. Let me get the turning point there. Okay, so they only want the x coordinate of the point to the normal. So that's done. If we were to wanted to find the turning points, not just the x coordinate, we would need to sub these values, -1.5, into the original equation to get the y. So I just want to show you, I mean, we're not going to calculate it, but I'm just going to show you, if you were to find, if they wanted the points, not just the x coordinate, we would need to say y equals, and into the original function, so that x minus 1 over x minus 1, we'd have to replace that x with a -1, -1, minus 9 over -1, -5. And that value here, you can see it's just a number, would give us the y value. And so my turning point would be then x, which would be, would be -1, and then the value here of this y. And that would be our turning point. Now they want the nature of each point. Okay, so they only want the x coordinate. So we just gonna, now we find the nature. Well, the nature is simply just when we find the second derivative. Okay, so let's write down our 2 points so that we remember them. So it was x equals -1 was the one coordinate, and x equals 1/2 was the other coordinate. Now, when we want to find the nature of the coordinate, we want to find out, is it a maximum or is it a minimum? Okay, so we found our derivative, which is here. So I'm going to delete everything except the derivative, because what we need to find is our second derivative. Okay, so we found our derivative here. Now we find our second derivative. Well, that is simply now doing the chain rule again. Okay, so I'm going to do the inside-outside rule. So we're going to take a bit of time on this and do it with me now, because we've done it the first time. In the first derivative, we're simply going to be using the chain rule again to find the second derivative. Now, the second derivative tells us the nature of the turning points. In other words, is it sort of concave up or concave down? I'll explain that once we figured this out. So inside, outside. So second derivative means the derivative of the derivative. So -2 times -1 outside first gives us 2. Sorry, we're doing color coding this. 2. Leave the inside alone. We'll do that later. -2 minus 1. So we take 1 off the exponent, becomes -3. Next bit here, -2 times 9 gives us -18. And then leave the middle alone, and then -3. Now we forgot to times it by the inside. Yeah, because it's inside-outside rules. Well, the derivative of x minus 1 is just 1 once again. And this is just 1 once again. So we're timesing by the derivative of the inside. So I did the outside first and then the inside. So I like to call it the outside-inside rule. But other people do the inside first. I just find that that way, if you end up with negatives, it becomes quite confusing. Whereas if you just tag this along on the end, you can then figure out if it's negative or positive much more simply. So now we have our second derivative, which is then 2x minus 1 to the -3 minus 18 x minus 5 to the -3. Now, we don't have to solve this because it's simply saying what is the nature. And so we know that so this is now what you've got to learn. So when our y dash is greater than 0, what do we know? We know that that is, so when you are greater than 0, you are positive, meaning you are happy. So if it's positive, if you're happy, you see that when you are happy, you have a minimum over here. And when y dash is less than 0, you're sad, negative. If you're a negative person, you're generally sad. And so that would be negative. And then you have a maximum. So now we simply just substitute in our x values of our two stationary points into our second derivative to calculate if it's positive or negative. Okay, so y dash equals, so let's do the -1 first. So I'm going to remove this. So we've got that thing, remember? So if it's positive, happy face, minimum. So let's see if this is positive or negative when we sub in things. So y dash equals 2 -1 -1 to the -3 minus 18 -1 to the -5 to the -3. Okay, so now you put this in your calculator to see if you get a positive or a negative. Okay, so I'm going to just do this in my head quickly. So we'll have 2 over -2 cubed minus 18 over -6 cubed. Okay, so this first bit here is going to be -2 is going to be -1. It'll be 2 over 8, right? 2 over -8, so it'll end up being -1/4. This bit here will be -36. Sorry, there'll be 3 of them. So -216. And so -18 plus 18 over 216, which is getting 1 over 12. And so it's going to be the more positive because more negative because a quarter is bigger than a 12th. So this one will be negative. So it'll be concave down, which, yes, down, and so then it's a max. So this one will be a max over here, which makes sense because it looks like it's a curve up. So then I sub in my half, I should get, it looks like a min, I should be getting a negative. Okay, so remember this one, the final answer was -3 over 4 plus it'll be -2 over 12. 6. Okay. You can always put this in your calculator. I may have made a mistake there, but the main thing is that it is negative. And that's the point. If it's negative, the negative tells us, so this negative here tells us that it's a maximum. Sad face. So we have a max. And then let's find out for our half. So this is a max at x equals -1. We'll do the half next. So I'm going to do it on the, I think I can fit it here. Half 2. And then I'm subbing into this value. So it'll be a half -1 to the -3 minus 18. A half -5 to the -3. And so we get 2 over, this will be -1/2 to the cubed. That's 18 over, that will be -5. So it will be 10 over 2, -9 over 2 cubed. Okay, so this one will be then -1/8. So it'll be then -16. And this one here will be plus, and then that, oh my gosh, 9,272 over 1/4 times 9 times 9. Okay, well, we cancel. So this one, we could actually just be clever here and we could just say 9 times 2 over 9 times 9 times 9. This would end up being a plus over 2. And so we know that the 9 and the 9 cancels. And so we get 2 over 81 over 2. So it'll be 4 over 81 plus 4 over 81. Well, 4 over 81 is clearly much smaller than minus 19, minus 16. So minus 16 minus plus 4 over 81 will still give us a negative, which we were hoping, because our negative means a relative min. So we know we have a minimum at x equals a half. Okay, now for this calculation here, you can just put it into your calculator. Okay, you don't have to do it in your head. So those are our two answers. We have a max at x equals 1, -1, and a min at x equals a half. So I'm going to stop the video there, and we're going to do a next time. Okay, because I don't have enough time.